So you guys have abbreviated configurations, page 43. Page 43, and you've got 1.12d, which was construct argument based on quantum mechanical model that explains periodic trends. Again, periodic trends is the next topic that we're going to be talking about, but right now we're just really figuring out what these quantum mechanical model show us, and then 12g, analyze and make conclusions about properties based on these orbital diagrams. And so really we're just diving into these more and looking at ways that we can abbreviate these orbital diagrams and make them a little bit quicker, depending on what our needs are. Okay, questions on what we're doing? All right, cool. So again, you've got your questions and summary section set up on your notes. And the first thing is same rules as what we do in the orbital diagrams. Aufbau principle saying you got to do it from low energy to high energy. Pauli exclusion principle saying you can only have one up arrow and only one down arrow, right? And then Hund's rule saying you've got to fill them up individually before you fill them up singly. Now, the cool thing about these first set of abbreviations is that only this first principle actually comes up, okay? So Aufbau principle is the only one that you really have to actively engage with when you're doing this first set of abbreviations, because you're not having to show the up and down arrows, okay? We abbreviate that part of the configuration, all right? So with that, before we dive into this, I'm just going to ask you guys, where do the orbital diagrams come from?
The periodic table?
Yeah, you got to get it from the periodic table. So if you aren't provided with one, what do you guys do? Yeah, you just make one. Now, with that being said, what we're going to do today helps you guys do that a little bit more quickly without having to go into all of the details if it's not necessary. But we talked about last week how we've got the different blocks of the periodic table, so that S block, P block, D block, and F block, and how you can relate those to those orbitals, and how you can really quickly check your work by referring back to these, right? So if I had like magnesium, right, in the S block third energy level, the last thing that should have, what's the last sublevel we should write there? S, and then what energy level? 3. So you should, whenever you get your orbital diagram or electron configuration written out, the last thing you should have is 3s, and it's in the second column, so how many electrons should be there? 2, unless it's an ion. If it's an ion, then obviously it lost electrons or gained electrons. So, all right? So it's a little bit easier to read to look at it this way, but you guys, again, are really solid with this so far. So, if we had to do element 118, all right, that's not on the periodic table here in the back here, but it is that last noble gas. If we had to do element 118, first think about how many energy levels would I need there? I'd need 7 energy levels. So on my configuration table, I'd need to do what? All the way up to 7. So let's do that real quick. We've got 1s, 2s, 2p. Third energy level is going to be what, Fisher? What's going to be my third energy level here? 3s, and then?
3p.
And?
3s.
Awesome. Thank you, sir. And then Travion, fourth?
4p. 4p. And 4f.
Absolutely, absolutely. And then, Destiny, what about 5? Right, and there's another one, but it doesn't actually affect what we've got here. And then Emily, 6th? What's the sixth energy level going to look like? Mm-hmm. And again, more, but we don't ever get there. And then Tyrese, yeah, or
I was about to ask about like why do you put a G after?
it's a great question. Yeah, so there is a 5G and there's a 6G and 6, I think it's H here. On the periodic table, there's literally not an element that goes that high. So, yes.
Actually, if you really wanted to get more precise, 6F would have to be included.
I think you are right that we don't have to go to 6F either.
And then I would just go 7, 7P, 7D.
Yeah.
7S, 7P, 7D. And again, 7F wouldn't be necessary either.
And 7D wouldn't.
Awesome. Yep. So then at this point, that would be everything that I would ever possibly need on a configuration table. And I would go in what order? Brianna, how would I know my order? Do you remember how we go through the configuration table? Up and Destiny? Yes, exactly. So we'll go through like that there. Okay? So the same thing with these abbreviated configurations. Okay? So let's try a couple of these. You'll see these called electron configurations. So you had orbital diagrams. What did orbital diagrams have? Colin? When you drew orbital diagrams, how did you show the electrons? How did you show the electrons? What were they? The arrows, exactly. So electron configurations, instead of showing arrows, they use exponents to say how many there are. Okay, so everyone find beryllium. Find beryllium, 10 seconds. Do you have periodic table?
Yeah.
Okay. All right, how many electrons for beryllium, Brent? Awesome, so 4 electrons. That configuration table says first I'm going to go into the what, John? What's the first sublevel?
The first sublevel, 1S.
1s. So far, any difference from orbital diagrams? None at all. So then here, S has 1 room, which means that can hold 2 electrons. I'm going to write an exponent of 2. Okay? Okay? I need 2 more. So after the 1s, what's going to fill up next, Fisher? 2s. That can hold a total of 2 also. So 2s, 2. I've got a total of 4 electrons, so that's my electron configuration for beryllium. Questions? What questions do you guys have?
I was so confused. I was like,
John?
Did you put A, and then 2S?
You would be able to do that. That's going to be the other thing that we're going to talk through. Yep. So this is the first type of abbreviation, is just getting rid of the arrows and abbreviating that part.
Okay.
And then the second part will be doing abbreviation with noble gases. Okay? So then nitrogen is going to be how many electrons? So we've got 7 to place. First we're going to do 1s. That'll be 2. 2s, also 2. That gets me to 4. What's going to be my next sublevel to fill in? Awesome. 2p, which can hold a max of how many?
3. Oh,
Right, so it can hold a max of 6. It only needs 3 more to get to that 7, though. Do what? You just put that there's going to be 3 electrons in there. Okay?
So the exponent just have to add up to the electron. Right?
Exactly. That's how many electrons are in each sublevel. So then you're going to add those up and make sure that they get to your electrons. Magnesium. Do you guys want to try magnesium on your own?
Yeah.
All right, go for it. All right, back together. We've got magnesium. How many electrons do I need there? Tyrese?
Oh, all right. So
Well, first, how many electrons? You're good. 12 electrons. And it sounds like you're excited. You want to go ahead and go for it? Okay. Okay. Awesome. And 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. Booyah. All right. Then let's skip down to iron real quick. You guys try the electron configuration for iron. Go. We've got then, how many electrons do I need here, Emily? Awesome. So 26 for iron. And we've got, the order of that needs to be what, Harley? It could go up to how many?
like 10.
It could go up to 10. I just needed 6 to get to my 26, okay? Cool. Then, go ahead and for each of these, see if you can figure out which element each of these are, okay? These are all neutral ion or neutral atoms. See if you can figure out which of the elements they are. Go. So this first one, how are we going to talk to me about what we could do to figure out which one this is? Destiny? Add what?
The exponent.
Okay, so add all of our exponents. We end up with what? 9. So then this should be what element if it's neutral? Fluorine, F. Okay? Then we're looking at this second one. You could use the same strategy that Destiny just shared with us. Add all of those up. What does that get us to? 21, which means that it'll be what? SC. Okay?
You have to write it out, the element. Okay.
Element symbols are totally fine. Now, remember, you guys have a cheat code, right?
Yeah, we have a periodic table.
So I could also, as long as this follows all of my rules, it goes in the right order, I fill up all of my orbitals before I move on, all of my sublevels before I move on. Which block of the periodic table will this be in if it ends in 3D?
It's gonna be like in this middle.
In the middle, that D block, the transition metals. Okay? Point to transition metals. I did not tell you guys when we talked about the transition metals and the D blocks before, but D always is 1 less energy level, and F is always 2 less energy levels. Okay? So point to the D on your periodic table and go over to the energy level on the top row. So the top row in the D block. What energy level does it say it's in?
The fourth?
The 4th, but D's are always 1 less than that.
Okay.
So that top row in the D is actually 3D. So 3D, 1 would be the first element in that top row of D. So that's another way that you can check that really quickly. Now, adding up the electrons, going to work for you every time. We've got this first one, number 3. How many electrons are here? How many electrons are here? 34, which means that if it's neutral, it's going to be which one? Selenium, Se. Then this last one, how many electrons? 52. Which means that it's going to be tellurium. Te. All right, questions on either of those? Can I count them?
No, not you.
Okay. All right. Then, what happens if they're an ion? If they are a plus charge, would that be losing or gaining electrons? Losing. So then this Na, I'm going to lose an electron and then do my orbital diagram. I'm sorry, my electron configuration. Okay? So you guys figure out how many electrons would any A have normally? Harley?
11.
It would normally have 11. It's got a +1 charge, so it's going to lose 1. That's not what I wanted. Lose 1 and have 10 electrons. So then if I'm wanting to do an electron configuration of this Na +1, then I'm going to do 1s2, 2s2, 2p6, and that'll get me to 10. Okay? So Na would have been 11 at 1s2, 2s2, 2p6, 3s1. But because I lost an electron, this is what I'm got. Destiny.
Didn't we do one of these problems like last week or something?
We did something similar. We talked about if they lost an electron, what would that look like? Yes. Kim?
So if we show them that that diagram right there, and they're like, oh, so it adds up to 10. Does that mean that it is big?
That it what?
Like,
How would you show that we took out the?
well, it obviously.
Ooh, that's a great question. So you would have to label it as what element it was.
So we would just have to like write down the question basically. Like Na equals.
Right, Na +1 equals, and then the thing. Okay? Now, in the same way, if I give you an electron configuration and don't tell you the element, right? So like if I gave you this electron configuration, it kind of actually looks like what element? Neon. It looks like neon. So if I don't tell you, then this is actually one of the ways that I could ask a question is, what elements or ions could this be? And if Ne is an option, you'd have to pick that. If Na +1 is an option, you'd have to pick that because both of those would have 10 electrons like this. Okay, questions on what I mean in there? Okay. Then let's do F real quick. How many electrons for F? Alex? How many electrons for F? 9. So then, if I've got a -1 charge, Caitlin, what would that get me to? Awesome. So I have 10 electrons. What will my configuration look like? Exactly. The same exact thing. So 1s2, 2s2, 2p6. Okay? And that's, again, why we use, because like you guys just told me, neon is 10, so it would have a normal configuration of 1s2, 2s2, 2p6. So then that's why when we do abbreviations, we reference the noble gases for that, because they're all trying to get to their noble gas configuration. So that's why we reference them. Okay? So, in summary, you need to be able to create those electron configurations for an element or an ion, And then you also need to be able to work that backwards. So I need to be able to give you an electron configuration and ask you what element or what ion might this be. Those are the two ways that you need to be able to work these electron configurations. Okay, questions on that?